Okay, good afternoon. Thank you for your participation. My name is Kenny Huang. I'm going to introduce the local language support from the afternoon section. Okay, let's get started. So the internet service scenario regarding to local language support in this lecture are going to cover in this few scenario. For example, from your client, connect to DNS, connecting to web service, web page, connect to an email server, or connecting to instant message service, or connecting to other, which ones are not covered. If it is not standard protocol when I cover in this lecture. Okay, let's start in from standard DNS terminology. And most of you probably are familiar with DNS behavior, so I just try to brief in what's basic terminology covered in the DNS application. Usually we say root servers. Root server has their database, and they have IP and top-level domain name, top-level GTLD server. So every server knows at least two root server, which is turned now is all top-level domain. And we also have a DNS client. For example, we try to request a lookup service from our application. Usually we call it DNS client. And the other very similarity function called DNS resolver is very similar to DNS client. But resolver has a very specific application behavior. For example, you need to go to DNS, provide recursive service until the IP address has been resolved from the dedicated DNS server. That's we call it. This kind of behavior is DNS resolver. And also we have DNS server. That's why we have DNS server locate all kind of DNS database or provide all kind of registration under the DNS database within the zone, DNS zone file. So go to the DNS database. You can look up what's the mapping between IP and domain name. And of course, there are so many attributes within the DNS server, such as mail exchange, such as the other attribute of the DNS. And there are several kind of attributes within the DNS server. So starting from IDN, IDN stands for Internationalized Domain Name. International domain name. First of all, we need to distinguish what's different between language and script. So the language is a way that humans interact, such as I speak English with you. That's a language. That's a part of language. When you go back to your daily life, you probably speak Mandarin, you probably speak Cantonese or Indian, or we speak in different languages to interact with the people. That's so-called language. A script is a written form of language. So many written language, they share same script, such as like a Mandarin, or we speak Mandarin in different kind of local dialect, but we use it in the same script. And some written language are using more than one script. For example, like that's in Chinese called 现代.com. 现代 stands for modern. And this script, 现代.com, actually not only used for Chinese society, but also used in Japanese society and also used in Korean society. Because these two characters was a shared script within the CJK community. So based on what we get from the script, it's hard for us to understand what it stands for Chinese or Japanese or Korean. That's why we need some sort of coordination effort to understand how we can map in the terminology, the address, and the meaning from what we understand. And the other concept is internationalization, localization, and multilingualism. Internationalization makes a protocol available to handle more script. That's why for IDN, starting from internationalized domain name, that means that kind of protocol, that kind of technology can handle multiple different kind of script together. That's internationalized. Localization involves tailoring interaction when user in the language they know. So localization is mapping to your local language you know, in the local script as you're familiar with. Multilingualism made a protocol able to handle multiple language. Okay. So domain name server, the purpose of domain is very old internet protocol. So even in the very beginning, such as ISO 1034, 1035 already defined what's the purpose of the domain name. And addressing before domain name was DNS was introduced. Basically, before the domain name was introduced, we're using a host table. For example, like in the Unix, we use etc hosts that provide IP and domain name mapping. So from the local etc host file, we can find the lookup from the domain name to the IP address. That's what traditional way to do, like a Windows and Unix etc hosts. And DNS is a distribution system. So I can, for example, we have GTLD and second TLD. That means DNS was being dedicated to different registrar. They manage the DNS server. And also it's a hierarchical and delegation-based operation service. It's a tree structure, so it's delegation of the responsibility. So that's a DNS element from the internet ISP, basically internet host, they run in the application. The application goes through the resolver. Those resolvers send a query to a DNS server. And DNS server find out the destination DNS server who is responsible for register the domain name and responds the IP address to the host, then making the application connection. So that's very similar, another different kind of perspective. That's DNS resolution process. For example, application, for example, you have client here, you send to a resolver submit to the root server, and root server tell you who will be the GTLD server going to respond for the IP address. When you go to the, for example, like in this example is .com, APSIG.com DNS server, they will tell you which final DNS server is going to hold in the IP address repository. And you go to the final one and get the IP address mapping. And finally, response to the resolver. Resolver get a response to the DNS client. Okay, that's a very similar one. I just skip this page. So from DNS point of view, which we learn in TCP/IP by protocols by different layer. So which layer belong to the DNS? It sounds like an application layer, but actually it's just halfway there. For example, in the third layer we call Internet Protocol layer or network layer, and the upper layer is TCP or UDP layer. One step up, you go to DNS first. So we can consider DNS will be the infrastructure service of the application. So after the DNS, you go to different kind of applications such as World Wide Web, such as email, such as other kind of application. So DNS just become the fundamental of the application service. It's part of application, but it become the fundamental of the application service. Before you connect to the different kind of application, you need to go through DNS first. And IDN, of course, will rely on the same tier as the original DNS service. Okay, that's how IDN design. The final IFC is IFC 5890, Internationalized Domain Name for Application. That means the IDN was designed to handle that kind of internationalized domain name within the application initially. But there are different kind of approach, try to find a proper solution, proper response. But from IT point of view, they try to handle internationalized domain name issues. So they move to one step, say, I provide that kind of capabilities. You can deploy internationalized domain name service from this point of view. But there are still many problems need to be resolved because only protocol available is not good enough. We still need to combine with different kind of service. I will explain later. So from IDN design consideration, we need to consider stability because as I mentioned, DNS is not only the application service, it's a fundamental application service. If DNS crash, everything gone, the whole internet gone. So when you design a new DNS service, you need to consider the stability. Also need to consider backward compatibility because internet running for decades and a lot of applications running on the legacy DNS service. So if you propose a new standard for DNS protocol, you still need to consider backward compatibility requirement and also need to consider easy to use and internationalization and also matching. Matching, for example, like here, Yahoo.com, small capital, and to Yahoo.com, that's capital domain name, capitalized domain name. For Huaren.com, that means Chinese in traditional way, traditional Chinese. And also Huaren.com, that's in simplified Chinese. So all that kind of different kind of script should be able to match each other. So to fulfill that kind of function, only rely on one IETF IFC is not good enough. So we try to solve from different way, try to mitigate that kind of situation. So what problem we're going to have, even we have internationalized domain name? That's one problem, that's quite famous one problem. 2-point power of impossible combination. For example, we have 3 characters. And probably many of you doesn't realize Chinese or Japanese or Korean, but it's fine. You can see the first character, it looks like it's very similar. Second character is still very similar. For third character, it's still very similar. So for both combination, I think it's very hard for you to distinguish that kind of similarity. But from user point of view, actually that should be, that create a confusion because you don't know which one belong to which. So we need to find a way to standardize that kind of query. Based on the right-hand side, that's all the Unicode is same for. So you can see actually there are different Unicode in a different column. Even they look very similar, but they are different Unicode. That create a confusion if you key in the wrong character, but look like a very similar. That create confusion. That's why we're trying to solve. How we're trying to solve? We define the problem space. Initially, the problem space for 2-point power of n combination character would be a very large namespace. So what we can do is try to reduce the maximum large namespace until reduced to be a more manageable domain name space. For example, registered domain name probably just one combination here. But when you query the name through your application browser or DNS client or the other application, probably hit to in different namespace but look very similar. So if we can regulate that kind of input and also regulate that kind of registration, we can restrict that kind of behavior become more manageable. And that's potential way to do. We propose a validation solution. So the validation solution is we set some limitation. When you register the domain name, you need to follow some sort of rule, some sort of guideline. So only very selected character can be entered into the root zone file. And also, when you try to query from your application, either browser or either DNS client, we regulate that kind of application behavior or try to limit only certain kind of acceptable character can be entered into that kind of application. So make sure the query namespace and register namespace, they are highly correlated. Still, problems still exist, but at least we reduce the problem space to a manageable and reduce to a more effective domain name query. Okay, that's the combination for validation measure. For example, still 3 character for Chinese, traditional Chinese, and simplified Chinese for Japanese, for Korean. Once you have validation measure, you can minimize the nonsense idea. For example, if the combination is combined Chinese, Japanese, Korean, that becomes invalid because you put 3 kind of string together, that becomes invalid. So we're using the validation measure, for example, O in 1 stand for is all valid in traditional Chinese. So that string can be accepted to enter DNS zone file. And for example, that's O valid in Korean. So these 3 characters can be registered into the DNS zone file. So that's validation measure. So going through that kind of exercise, you can see original combination could be a lot namespace. But after validation, only the 1, 2, 3, 4, 5 reduce the effective namespace become a 5. So we still have small amount of problem, but we reduce the problem size to a minimal problem size. It doesn't work anyway. It's stuck. On the next page. Oh, okay. Oh, okay. Fine. Okay, that's good. Okay, that's another example how to introduce that kind of validation method. For example, you have CJK from Chinese, Korean, Japanese, in different color. For blue color stand for Korean script. For red color stand for Japanese script. For yellow color stand for Chinese script. So once you enter the whole stream as a domain name, you can go through that kind of validation method. For example, if the domain name somehow here is not registered within the code space, that become valid. But if you combine different kind of script into one string, and that will be invalid. So through that kind of exercise, we can try to reduce the problem into a more manageable size. So how we solve the problem from the architecture point of view, and that's the overall DNS architecture. For example, in the left-hand side, you have registrar system, you have register system. Any domain name holder, they go to registrar to register your domain name, and they go through EPP protocol, put your domain name into the DNS server, and also you update to the master update dedication to the DNS, and then from user point of view, they trigger the resolver to get a DNS query, to send the DNS query, get an IP response from here. So the problem space for IDNA, as I mentioned, from the IETF, they try to solve the problem from this part. They try to standardize the communication protocol between DNS client and DNS server. That's from IETF point of view. And from IDN registration point of view, we try to solve problem from this part, registration part. That's how we come out with the IFC 3743, and that's IDN administration guideline, try to regulate registration behavior. So we try to solve the problem from both sides. The other one side is from IETF protocol, communication protocol point of view. The other side from registration service point of view. Try to match both sides, reduce the problem space into a more manageable domain. That's another example. What sort of policy and resolution could be? There are three scenarios. For example, you have DNS client, you send in multilingual DNS client. There could be a 4 variant in the DNS zone file, zone file. And when you go to DNS host name, they probably only activate 2 of it. So that will create a problem. For example, if the other 2 name was not found in the application, the communication will become disconnected for that kind of behavior. And that's another example. If the host name repository they didn't activate the domain name but already reserved. So these 2 reserved names still put it in the repository reserve. But the last one with full registration policy, that means all the combination of DNS, all the IDN variant will be once you register here, and that will be fully activated in the DNS server. So IETF spent a lot of effort on the internationalized identifier. For example, starting from 2004, starting from different kind of IFC 3743, and they come out with even IoT both, like a WILE working group, and they have IFC 6855, and the last one last year was 7870. So there are tremendous effort on the internationalized identifier. From IETF point of view, they spend a lot of effort to make things happen. That's all the IFC list. You can go to the details. See, if you are interested in the protocol detail, you can select from the IETF IFC, choose the number. So I'm going to introduce the other application point of view. I'm going to introduce internationalized email. So email is an essential element of the business card, especially from Chinese community, because only domain name is not good enough. If you cannot send email to someone else through internationalized email, it's not very useful because only domain name is not good enough. But internationalized email not only covers domain name part. In the right-hand side is the domain name part. You also need to consider from user point of view, username. From username part, you need to able to enter multilingual username. So you need to design the solution from both sides. The right-hand side is a multilingual domain name. Left-hand side is a multilingual username space. That's what EAI did. For the EAI working group, actually, they already published a lot of standards. And a lot of vendors, software vendor and service provider, they already deploy the EAI standard, such as the information I quote from Dr. Kong, such as CNX, they deploy EAI, Sun Oracle, and Qualcomm, and also Microsoft, AT&T, Google, they all adopt the EAI standard. Okay, there's similar situation. The EAI implementation not only from software point of view, also from different industrial forum, and they try to promote that kind of activity to promote user, try to use internationalized domain name. For example, like here, that was EAI has been introduced in the APEC. So encourage the APEC member try to promote EAI internationalized email within their jurisdiction. So people will be able to submit the multilingual email through each other. That's IETF-Y working group. Y stands for Web Extensible Internet Registration Data Service. They try to standardize all the HTTP support different service level to different classes of users. Another concept is universal acceptance. That's a subgroup of the ICANN. Universal acceptance, that means all the domain should be operate equally, such as their acceptance and their validation, their storage, their processing, their display. Because as I mentioned, multilingual domain name or multilingual email, they cover different kind of service component. Not only happen from protocol point of view, but also happen from registry point of view, or also happen from operational point of view. You need to deploy the service from different kind of service component. So universal acceptance try to validate each part of the service component. They fulfill the requirement to support IDN or EAI or IRI, internationalized resource identifier, support that kind of feature, make sure all the multilingual effort can be happen from different kind of application from different region. So that's what Universal Acceptance Steering Group, they have 4 groups, like top line technical issue, international issue, measurement and monitoring, and the community outreach. So they have also tried to promote that kind of concept, encourage service provider provide user acceptance certified service. Or the information from UA group, the UA, let's define the UA readiness from the ICANN sponsored program. For example, like only 30% externally hosted, they are verified by Universal Acceptance. 70% of internal hosted support UA, and 42% non-source code access can be certified by UA. 58% access to source code was certified by UA. So the L10N and I18N stand for localization. That's in brief. L10N, internationalization, is I18N. That means adopting computer software to different language, regional different technical requirement of the target market. That's whole process for localization process. I'm not going to introduce the more detail, so you can just skip. Okay, last one will be local language support. For example, we're using the instant message from our smartphone. So basically, instant message goes through the IM server. They relay the message to your communication partner. So all the most likely instant message application rely on default setting of smartphone operating system. So is your smartphone support multilingual? If your smartphone support multilingual, based on your default setting, they use the default setting to communicate with your counterpart. For example, like default setting encoding is UTF-8 for iOS and Android operating system. So user based on their preferred language, they can choose their preferred language encoded by UTF-8. So that means all the communication with your partner will be encoded by UTF-8. So the last one from technology point of view, that was being discussed within the IETF, but unfortunately the discussion was not continued, but it's still very valuable because you probably the first time hear that kind of new architecture. So you still had the opportunity to extend that kind of research. It's considered as a research program. The concept was proposed by John Clanson. We call IRNSS. That is a layer search service. First layer, as we mentioned, DNS. We can say DNS is an identifier mapping because it's just doing very stupid things from domain name, direct mapping to IP address. So it doesn't provide any intelligence at all. DNS is just a name and address. It's no intelligence at all. So a lot of people try to make a DNS more smart, but eventually that kind of effort doesn't work out because DNS doesn't have that kind of capability. And it was not designed to provide that kind of intelligence as well. But from user point of view, basically, we don't need a very dumb service. We need a smart service such as Google provide. You just key in a string, it provide a bunch of return you like. So that's a commercial search service. But from internet point of view, we definitely can find a way, try to find something a little bit smarter. For example, we define this is layer 2 search. Layer 2 search is a restricted search system for IRNSS, stand for Internet Resource Name Search Service. That was proposed by John Clanson long ago, and unfortunately the research didn't keep going. Hopefully one day you can reactivate that kind of research. I think it's very beneficial to all the community. And for layer 3, as I mentioned, everything we looking for, we just go to Google, go to somewhere. That's commercial search. A commercial search, that means you can choose which search company you like and just key in the string you like, get an output from the search company. So what's different between layer 2 and layer 3? Layer 2, according to John Clanson, they provide 3 attributes. The first attribute is language. Second attribute is geographical location based on where you're looking for. And the third attribute was industrial category call, such as we can get industry standard call from WIPO NIST list, or we can get an industrial call from International Classification of Goods and Service. So that's potential source. You can get an industry category code. And also network location network can be developed. So how the IRNSS can provide a function? Oh, okay. From language point of view, language facet, you can follow IC 3066, the number 36. There identify language tag to identify which language tag you use. And also, there are different kind of source for language tag, such as IFC 2860. And also, iSource have standard 639, standard 639. So that means you can reference different language tag. Once you have standardized or agreeable language tag, you can key in the search. So the layer 2 search service will based on your language tag to identify which database will be appropriate for your search. For geographical facet, you can base on, as I mentioned, you can base on ISO 31666-2. That's a list for country. For example, like a DE-BW-DSTR stand for struggle. And also, you can reference to different search, different lists, like a UN have a LOCOD list. There are about 26,000 names for port, airport, rail terminal, rail station, post office. They have a huge list, 26,000 list name for the port. Okay, so when we provide a query, and we can identify which country you're going to query, or identify country and subdivision. And also, we can provide country, subdivision, and city. So they can provide some sort of more smart way to do that kind of search. And also, one thing is very clever, is the geographical fuzziness indicator. That means you want to precisely search, like DNS. DNS is precise search. You key in the string, and once the string can find from the zone file, it gives you the response. But once the string couldn't find from the zone file, and you got no response, that means that's exactly precise search. And once we can have a geographical fuzziness indicator, that means we can adjust the parameter, provide a little bit fuzziness search. For example, the indicator if 0 stands for exactly search. And if the indicator stands for 1-0, that means match next level. For example, search the country first. If the country first, you couldn't find the result, go to the city subdivision or go to the city. If the value is 99, that means you search everything once you can find from the IRNSS domain, or search everything. Okay, does the provide some sort of validation? For example, geographical location that can be validated according to ISO 31666-2. And industrial category can be specified by the WIPO NIST list. So that means everything we reference from has a very standard format. So that for us, or for internet architecture, it's easier to identify, to validate whether that kind of search is valid or not, because everything was being regulated. Okay, from architectural point of view, we need to consider that kind of technology should be implemented within the client or should be implemented in the server. If that kind of technology implement to the client, that promote the performance, because client has a distribution computing power, they have more higher performance. And you can try to localize different kind of requirements, such as local language and local terminology. And if you implement that kind of technology to the server, that involves everything should be unified, because the server is a centralized concept, such as the root server. Everything put in the root zone should be unified. So you need to coordinate between different kind of language community. Make sure there's no overlap between all the script. Okay, last would be the service scenario. Initially, when you submit the service, you just submit any language, any terminology, submit to the local translation server. For example, I'm going to find where is the best restaurant in Bangkok. I just key in here. Go to local translation server. And local translation server tell you, they find a keyword, restaurant, Bangkok, and they give you some sort of recommendation. Go back to the client, or you can call resolver. Then the next step, the client submit to the IRNSS server. As I mentioned, IRNSS server was highly regulate service behavior. So only certain registry are eligible to provide that kind of service. It's not a commercial search. So only authorized agency can run that kind of service. So if, for example, they give you some recommendation, the first translation service tell you Bangkok restaurant, what will be appropriate IRNSS service you can look up. So they will give you instructions. Go to the Ministry of Transportation and Communication in Bangkok. They will provide IRNSS lookup service. So you go to the IRN service registry, and they mention the keyword like restaurant and also Bangkok. They give you some sort of domain name such as some sort of Friday Inn or TGI Friday, for example, TGI Friday. They give you a recommendation. TGI Friday could be some domain name. And finally, the TGI Friday, you go to TGI Friday domain name server. They give you IP address. Then, once you find the IP address, you can connect to the TGI Friday website, or connect to their email, or connect to their phone. So that's how IRNSS work. That's another example by geographical search example. For example, from the browser or from any application, the input method, you key in Singapore University in Chinese, for example, in Chinese. That's geographic search example. So the IRNSS, they identify Singapore that's been registered in the IRNSS that belong to such as Singapore Authority. They manage the IRNSS. So they refer the service query to Singapore Authorized Authority who manage the IRNSS server. So the Singapore Authority, you can do the translation, simplified Chinese character or traditional Chinese character conversion service here in the IRNSS server. So eventually they find Singapore and plus university. They give you a list, say Singapore.ac.sg. They give you the full domain name. So finally, your client go to the name server to look up, find out the IP address. Then you connect to the Singapore University. So that's how it works. So the access model for IRNSS, just like that. For example, in a starting from here, sorry. Local search, go to local search, they have intelligent mapping. They will refer you, you can direct go to DNS lookup if you enter a very precise domain name. You just jump over, go to DNS lookup. If you key in a very fuzzy string, fuzzy name, then they will refer to a IRNSS service registry based on 3 attributes, based on the location, based on the industry, based on the language. Try to identify who is the appropriate IRNSS service operator. Then we'll refer that kind of query to authorized IRNSS service operator. Then IRN service operator will respond to you what would be the proper domain name you should look at. Then eventually you could go to the third tier, go to the domain name, find out the IP address. So sounds very complicated because right now it doesn't look like our service scenario as we use daily from the Google, from Facebook, because from the Google you almost can get everything from the Google. But if you deploy that kind of architecture, it's very complicated and involve a multi-stakeholder to participate. For example, you need IRNSS service registry, authorized service registry. Service operator, you need DNS operator, you need a lot of validation service before you register IRNSS. So it's very complicated. Why not just use Google? Simple. Because internet was dominated by commercial company. Whatever Google give you, you have no choice. But IRNSS is a public service. It's been running by authorized public registry. They provide a public service. That means every user, every individual, every community, every country, you can have your choice. User can have your choice. You can either choose Google or you can either choose IRNS. That provide another alternative to existing search industry. But right now, everything we just rely on Google. Whatever Google comes out, we just believe it's true. It's been validated by Google, but it's not proper way to do the cyber. Our cyber life, everything just rely on single source. It's inappropriate. But providing IRNSS, everything has been public review. Even the operator, even their service model, their service quality is being go through a public review. That means let's provide some sort of accountability and transparency to the internet user, which we don't have from the Google or from the Facebook. Okay, that would be the IRNSS service model. As I mentioned, that was proposed almost 10 years ago, but unfortunately, that kind of effort didn't sustain because too much effort. But I believe for people like you still have a potential. You are a new generation. You can continue the mission. It's not too late to re-study that kind of model and try to repropose in the IETF. I believe you get a lot of support from IETF as well. So that's the IRNSS model I'm going to introduce to you. Okay, try to finalize what is IRNSS summary. So basically, it's a research-based model. As I mentioned, we classify into different attributes for IRNSS. For example, like by language, by industry, by location. And also, we didn't go one step further, try to distinguish what's different, what happened, what if different attribute was overlapped. For example, when you key in some string, some name, they have a language attribute, they also have location attribute, they also have an industrial attribute. How are we going to distinguish between 3 attributes? We didn't discuss that detail. But still, there are still potential way to research on this program. So the IRNSS provide local language and technical community need to accommodate a physical model to fulfill local requirement. What do I mean fulfill local requirement? For example, like a language attribute, location attribute, industrial code attribute. That's only from standard point of view. But from operational point of view, you need to delegate INSS service registry or service operator. That's from operational point of view. So the service operator need to be going through some sort of public review to certify. For example, like Singapore or Thailand, there are only one certified public registry are eligible to provide INSS based on the geographical attribute. For example, anything referred to Thailand, please send the query to my database. So only authorized agency will be eligible to provide that kind of service. So that's the best effort resolution. As I say, it's different from what we did in our daily life. Our daily life right now is fulfilled by all the Google search. But for IAN search, it's very complicated. But the effort is worth it. It's really worth it. From accountability point of view, from transparency point of view, it's worth it. So, and URI information can be included in the INSS service data field. So not only search for domain name, you can also search for internet resource identifier, such as a web link, still can fulfill that kind of function. Okay, it's 3 minutes left. That will be my introduction for my presentation. So I end it here first, then go to the next section will be question and answer.